Hi everyone, I will be going over a question on finding equilibrium concentrations from initial concentrations and the equilibrium constant. So, we are given the reaction N2O4 goes to 2 moles of NO2. A reaction mixture at 100 degrees initially containing 0.1 molarity of NO2. Find the equilibrium concentrations of NO2 and N2O4 at this temperature. Alright, so we start off by making an ice table for the reactant N2O4 and the product NO2. So we put that into the box. And for the initial concentration, we know that for NO2 it's 0.1 molarity. And we can assume that we have no N2O4 starting out. To calculate the change, we need to compare the Q versus K values. So to find the reaction quotient, we do the equation for the products over the concentration of reactants. So we get NO2 squared all over the concentration of N2O4. The squared is from the 2 moles of NO2 that we get from the reaction. And then we just plug in the values from the first row into this equation. This is essentially infinity because it's all over 0. Therefore, our Q is greater than our K, so our reaction favors reactants. When a reaction favors the reactants, it's going to go towards the left. So we will be making more N2O4 while we are using the NO2. Therefore, our change for this is plus X, and for NO2 is minus 2X. The 2 is from the 2 moles of NO2 that we are losing to gain 1 mole of N2O4, as you can see. And then to find the equilibrium concentration, you just combine each column to get 0.1 minus 2X for the concentration of NO2 and 0 plus X, which is just essentially X for N2O4. Next, we will find the equilibrium constant. We have the equation Kc is equal to the concentration of products over the concentration of reactants. Both are raised to their number. All right, so our next step is to plug in our reactants and products. So we should get the concentration of NO2 squared over concentration of N2O4. Then we plug in the row of values for the equilibrium. Oh, shoot. Okay. And then let's simplify this squared. And we should get 0.36 is equal to 0.01 minus 0.4x plus 4x squared all over x. The 0.36 is from the initial given value from the question. All right, so let's simplify this thing. Let's multiply both sides by x to get rid of the denominator to get 0.36x to 0.01 minus 0.4x plus 4x squared. Then let's subtract 0.36x from both sides, so all our values are on one side of the equation. We should get 4x squared minus 0.76x plus 0.01 is equal to 0. All right, this is a polynomial function, and it does not simplify nicely into finding the value of x. Therefore, we need to use the quadratic formula, which is written right over here. And then now we just need to identify what A, B, and C is. So A is 4, B is negative 0.76, and C is 0.01. All right, now we just plug it in, these values, into the quadratic formula. So we get x equals negative 0.76 plus or minus the square root of negative 0.76 squared minus 4 times 0.01 all over this entire quadratic formula. You should get the x values of 0.176 and 0.014. These are the x values that we plug in back to the equilibrium concentration equations that we got from the ice table. All right, so let's first start out by using 0.176 for NO2. We should get 0.1 minus 2 times 0.176. Well, 0.176. All right, so from that, you should get the concentration of NO2 is equal to negative 0.282 molarity. And since this concentration is negative, that cannot exist. Therefore, we cannot use x is equal to 0.176 for the value of x. Then we are just left with 0.014 as x to plug in back to these equations. So the concentration of NO2 at equilibrium is equal to 0.1 minus 2 times 0.014 to get 0.072 molarities of NO2. Then for N2O4, it's just the equilibrium reaction is just X. So the concentration of N2O4 is just equal to 0.014 molarity of N2O4. Now we have the final concentrations for NO2 and N2O4 at equilibrium. Our final step is to check our answer. To check our answer, we use the same equation from over here, which is just Kc for the equilibrium constant. So Kc is equal to the concentration of NO2 squared, from the reaction above, all over the concentration of N2O4. Then we plug in the values that we got from earlier into this equation. And we get 0.072 squared over 0.014. Then once you calculate that, we come out to 0.37, which is really, really close to 0.36. Therefore, our calculated value of Kc matches the given value of Kc, so our answer is valid.